Hi, so we're going to do another exercise in here. It's this, okay? I don't know if it's better to see it this way. So you want to find out the arc length of this arc in here, okay? From one dot to the other dot. From one point to the other point, okay? And the equation, the function is y equals ln of cosine of x. So let's do that. It'll be the integral, right? The square root of 1 plus this dx. As a matter of fact, it's going to be y prime. Okay, the first derivative of of y with respect to x, or dx squared. Like this, dy dx squared. Okay, that's what this is. Okay, so it's the square root, oh yeah, and it's going to be from 0 all the way to 1. Oh, not 1, hold on, it's not 1, it's pi divided by 4. So I'm going to change this into a pi divided by 4. So it'll be the integral from 0 to pi divided by 4 of the square root of 1 plus the first derivative of dx, dy with respect to x squared dx. So let's do this. What is dy dx? Let's do this first, okay? It's going to be 1 divided by the cosine of x times the derivative of the cosine of x, because the cosine of x is the inner function, which is minus sine of x, minus sine of x. This equals minus tangent of x. Okay? What is going to be this stuff squared then? So if I square it, it'll be tangent squared of x. So it's the integral. Oh yeah, there's something else. You see, 1 plus the tangent, or 1 plus the first derivative squared, equals 1 plus the tangent squared of x, which equals the secant squared of x. Right? That's one of those identities, trigonometric identities. 1 plus the tangent squared of x is the secant squared of x. So the square root of the secant squared of x is just going to be the secant of x. So it'll be the integral of the secant squared of x dx from 0 to pi divided by 4. The integral of secant squared of x is the tangent of x. So we're going to do tangent of x from 0 to pi divided by 4. The tangent of 0 is just 0. And the tangent of pi divided by 4 is 1. Okay? Or, oh no, sorry. Because it's the square root of this, so it'll be the integral of secant squared. Okay, this is the secant squared, but you have to take the square root, so it'll be the integral of this, not the secant squared, of the secant. Okay, now the integral of the secant is ln of the secant of x. I don't think I'm going to have enough room in here. So it'll be the ln of the absolute value, of course, of the secant of x plus the tangent of x. And I got to put another absolute value in here. Okay? And it'll be from 0 to pi divided by 4 So applying pi divided by 4 is going to be the ln of, well, what is the secant of pi divided by 4? The secant is the inverse, is the reciprocal of the cosine. The cosine of pi divided by 4 is square root of 2 divided by 2. So it's going to be 2 divided by the square root of 2. All right? Plus the tangent of this thing. The tangent of this thing, tangent of pi divided by 4 is 1. All right? Okay. And then you have to do like minus the ln of, let's see, secant of 0. Well, the cosine of 0 is 1, okay? So it's just going to be 1 minus the tangent of 0 is 1. The tangent of 0 is 0. So there you go. So when you do this in the calculator, this is going to be approximately 0.881. Okay, so 0.881 is going to be the length of this part right here. Now I'm going to do another exercise. Okay. Exercise is this. Okay, so you have something here. I'm not going to prove this to you, but you see this when you have wires that are hanging. Okay, you got a post in here and you got another post in here, and the wires are hanging, and you can see that the posts are 200 whatever apart, 100 to the left and 100 units to the right, and the value of y according to the value of x is going to be given by this catenary, I think it's called catenary equation, y equals 150 times the hyperbolic cosine of x divided by 150. Now let's see what this means. It means that y, and it wants the length, okay? It wants the length from here all the way to here. It wants this length in here. Right? Okay. So y is going to be equal to 150, and the hyperbolic cosine is just going to be e, okay, to the x divided by 150 plus e to the x to the minus x divided by 150. That is the definition of the hyperbolic cosine of x divided by 150, and you have to divide this by 2. But you got a 150 here, so I'm just going to turn this into 75. Okay, now let's check the derivative. The derivative of this, okay, is going to be 75, and then you have e to the x divided by 150 times the derivative of this power function, which is going to be 1 divided by 150. So you can put this 1 divided by 150 here, all right, plus e to the negative x divided by 150 times the derivative of this. The derivative of this is going to be minus 1 divided by 150. So I got to change this into a minus, and I gotta put 150 here. So you can join this together, okay? And you can just say that this whole thing, I forgot, it's not a particle. This term and this term are being multiplied by 1 divided by 150, but you have the 75 in here. So what I'm gonna do is to just simplify this whole thing, turn this into half, okay? So I'm gonna get this out of here. I'm going to get it out of here, and this I'm going to get it out of here. I'm going to put a half in here. Okay. Now we got to square this stuff. So this thing squared. Okay. It's going to be 1/4. And then we gotta square this, okay? Well, let's do it. It'll be e. Now, if you square this stuff, e to the x divided by 150 times e to the x divided by 150 is e to the 2x divided by 150. You sum up, you add up the exponents because you're multiplying with the same base. So 2x divided by 150 is just x divided by 75. So, like so, okay? Minus twice 2 times this. If you're multiplying this stuff by this stuff, because the bases are the same, you add. So x divided by 150 minus x divided by 150. It's 0. E to the 0 is 1. So it's just minus 2 in there. Okay? And then you have to put a plus and you multiply this thing here. So it'll be e, all right, to the minus x divided by 75. Just check one thing here. Okay. And then you have to add a 1. So, because, yeah, you have to add a 1. So 1 plus y prime squared. It's going to be 1 plus this. Okay. Now, e to the x divided by 75, you can't add a 1 there, and you can't add a 1 e to the minus x divided by 75. But you can add a 1 to this 2, okay? So it's going to be minus 2 divided by 4. It's minus half. Plus 1, it's plus half. So all we got to do is to do this thing here. I'm going to copy this. I'm going to paste it here, okay? Over here. But instead of using a minus 2, it's a plus 2. All right? Now you have to take the square root of this. Well, taking the square root of 1 plus y prime squared is going to be equal to the square root of this. But you know what? There's something else that I want to do first. This is like this, right? Well, this also equals to, I'm going to put a square here. It's going to be 1/2, okay, of x just think about one thing here. Yeah, times x to the, well, let me just think. You know what I'm going to do? I'm just going to erase this stuff. I'm going to do this. I'm going to put a 2 here, okay? And then I'll do, because it's 1/4 multiplying everything, so trust me guys, when you take this 2 here and square it, it's going to become 4 in the denominator. So it'll be x, no, not x, e to the x divided by 150 plus e to the x to the minus x divided by 150. Try to square all this thing, okay? Because the 2 is in here, you can put it out, and then squaring it, you're going to have this 1/4. All right, now just worry about the numerator. You have this thing squared is going to be this, okay? Twice this times this, it's going to be this. And when you take the square of this thing, you're going to go back to here, right? So this is equal to this, which is equal to this. All right, and now we're going to take the square root of 1 plus the first derivative of dy with respect to x squared. This is just because this thing is this, which is squared. Okay, all you got to do is to take the square out. So this is going to be equal to, I'm going to put it a little bit more down here, like that. There you go. It'll be equal to e to the x over 150 plus e to the minus x over 150, okay, everything divided by 2. I'm going to extend this in here like that. Okay. All right, there you go. And now you have to do the integral of this stuff, okay? Well, okay, so the integral, I'm already going to do the integral, okay? The integral of this is going to be the integral of this, and it will be from minus 100 to 100. So, yeah, it'll be dx, right? And it go from minus 100 to 100. Okay, so what did I do? Okay. So this 2, I'm going to take it out of the integral because it doesn't matter. Now I integrate this thing. It's going to be e to the x divided by 150, okay, divided by the derivative of this. So if it's divided by 150, you're multiplying by 150. So I'm going to multiply over here by 150, right? Plus e to the minus x divided by 150 divided by the derivative of this, which is minus 1 over 150. So you're multiplying by minus 150. So I'm going to take this stuff out. I'm going to put a minus here, and I'm going to put a 150 multiplying here. All right. Now you have a 150 here and you have a 150 here. You can just take the 150 out. I'm going to factor it out and divide it by 2. Okay. So actually what I'm going to do is to get this out of here. Okay. Get this out, get this out, get this thing out. Get all of this out of here. I'm going to put a 75. Okay, and this is a minus, and you close it here. All right, and now all you got to do is to replace minus 100, and you got to put a 100 there. All right. So let me just think about one thing in here. Just thinking, guys. Hold on. Yeah, anyway, okay. So we're going to do 75 times e to the 100 divided by 150. 100 divided by 150, okay, minus this e of minus 100 divided by 150, and then you gotta do a minus, right, e to the minus 100 divided by 150, e to the minus 100 divided by 150. You have this minus here, but because it's a minus, because you're inserting this value now, it's actually a plus. E, okay, we're going to do this e here now. Minus 100 with a minus is going to become a 100. So 100 divided by 150. All right. Now when you see you got an e to 100 divided by 150, e divided to 100 divided by 150, adding up. So I can just put a 2 here. Oh man, I'm going to erase this stuff. Erase, 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 and I'm going to put a 2 over here. Same thing with this thing, okay? It's minus e to the minus 100 divided by 150 minus e to minus 100 divided by 150. So you can just put a 2 here, okay? And you can erase this thing over here, bring this over, delete this, fine. Now this 2 is over here, so I'm going to factor this 2 out because you got a 2 here and you got a 2 here. I'm going to factor it out, multiply with that 75 on the outside, okay? And then multiply by e to the 100 divided by 150. Well, it's 10 over 15. Simplifying by 5 you got 2 over 3. So we have 2/3 minus e to the minus 2/3. All right? When you do that in the calculator, you're going to get approximately 215. 215 what? Whatever the unit is, okay? If this distance from here all the way to here is feet, that's going to be feet. If it's inches, it's going to be inches. If it's centimeters, it's going to be centimeters. So if it's kilometers, it'll be kilometers, so it doesn't matter. But the final answer is 215. Okay? And that's it, guys.